is sample data. So we will use the average function for the mean in Excel. And just select all of the data and press enter. Unless you misspell the word average, and then you have to fix it. And there you go. There's the mean and the standard deviation for the sample. There is a standard deviation, STDEV. Then you're going to do either .p or .s. If it's a sample like this one, you do .s. If it was for a population, you would do .p. I'm just going to select my data again and press enter. Now it says to report answer using the rule suggested in class or in the book, one more decimal place than the data. So the data has one place after the decimal. So we're going to round our answers. Well, for the mean, we're going to round it to one place more. So that would be 2 decimal places. And for the standard deviation, we want to go 2 decimal places more than in the data. So we want to go to 3 decimal places. And that should do it. So, whoops. We're going to go ahead and put those answers in. And then we want the z-score of the value 59 in this data set. And we want to report it to 3 decimal places. Also remember that it is best to use the unrounded mean and standard deviation for this calculation, not the values reported above. Okay, so although I did round them here in the Excel is still holding on to the true entire value. So as long as you don't type these numbers in by hand when you're calculating your z-score, you should be fine. So the z-score formula is you take the x value minus the mean, and as a quantity, you're going to divide that by the standard deviation. That's how you find a z-score. So that's basically telling you z-scores tell you how many standard deviations from the mean your x value is. So for this example, it'll be 54.0, sorry, the value they asked us to convert to a z-score is 59. So we're going to do 59 minus the entire mean, not rounded. So I'm going to do this like this, 59 minus the entire mean divided by the entire standard deviation. And then I'm going to round it to 3 decimal places. And we're all good on this one. Now there is one more question. That was it for this class. And my other online class had one question. So we're going to go ahead and I watched the video, but couldn't figure this out. Okay, so let's see what the question says. Okay, so for this one, I'm just going to copy a picture of this over so I can draw on it for us. And it says that we want the probability of a random variable x between that is at least 1.7. So we are going to find 1.7 on the x-axis, which is roughly right about here, 1.7. And then we will draw a line up to the density curve, and it says at least 1.7. So at least means greater than or equal. So we are shading to the right, and we want to find the area of this rectangle, the shaded region. Now, in order to do that, we do need to know the height of the rectangle. So remember that the height of your rectangle is the probability of x, and that is always equal to 1 over the range of x, because when you multiply it times the range of x, you get 1 if they're reciprocals. So the range of x in this example is 2 minus 0, because x can be anywhere from 2 to 0. And that means that since the range simplifies to 2, the probability of x is 1 over 2. And I kind of have some weird notation here. Let me fix this a little bit. We want to say that the probability of x is equal to 1 over the range because the area of a rectangle is equal to base times height in general. The area for our random variable should add up to 1, since all the probabilities have to add up to 1. The base here is 2, and that means that the probability of x, which is our height, has to be 1 over 2 in order to get an area of 1. So all that to say that the height of this side of the rectangle is 1/2, and in fact it's 1/2 here as well from the top to the bottom. So when we're looking to find the area of this rectangle, we'll need this base, which is 2 minus 1.7, so that would be 0.3, and we're going to multiply that times 1/2 to get our answer of 0.15. So the area of the big rectangle is represented here, but the area of the smaller region that represents the answer to our question, the probability that x is greater than or equal to 1.7, we had a base of 0.3 and a height of 1/2. So base of 0.3 times 1/2 or times 0.5, or half of 0.3 is 0.15. All right, and that's all the questions I had tonight. I hope you guys are doing well with these lessons, and I'll see you in the next recording.